Hello, and welcome to Zen 340. We are Team 21, and today we will be doing Problem 1. Now, before we start, I'd like you to go ahead and relax your shoulders, calm your mind, take a deep breath, inhale, now exhale. Good. Now, let's get started. Now, let's go ahead and take a look at the problem. In this problem, we have two tanks, tank A and tank B, connected by a pipe system, which includes joints, a manometer, and a pump. The goal of the problem is to find H, the manometer deflection. We will solve this problem using 7 basic steps. In step 1, we will write the variable being determined. Step 2, we will write down our known values. Steps 3 and 4 will include assumptions and relevant equations which will be used to solve the problem. In step 5, we will identify necessary diagrams and find the values that we need from these diagrams. In step 6, we will solve using known variables, diagrams, and the values determined from those diagrams, and the relevant equations from step 4. First, we will find the flow rate and find the intersection of pump and system curve by specifying the velocity, calculating Reynolds number, indicating the determined F from the Moody diagram, finding the flow rate, and finally finding the pump head. Then, expressions will be determined for the manometer and the pipe energy. Finally, we will combine these last two expressions to solve for our manometer deflection, H. This will be our final answer. Fantastic! Let's get started now. In step 1, we are writing the variable being determined. This is H, the manometer deflection. In step 2, we will write the known variables. This includes the pipe diameter, the pipe area, the pipe roughness, the pump head delivered, and the specific gravity of the manometer fluid. In step 3, we will write the assumptions that were necessary for calculating the problem. The first assumption is that the flow is wholly rough and turbulent. Also, the friction factor is independent of Reynolds number. In step 4, we are writing the relevant equations. Equation 1 through 4 are necessary for solving the problem. The diagram used in step 5 is the Moody diagram. From our assumption that the flow is rough and turbulent, we will use a high Reynolds number at a relative roughness of 0.01. This results in a friction factor of 0.038 as indicated by the diagram. We begin step 6 by using our equation 1, which is the pipe flow equation. Due to the free surface, P1 and P2 are equal to 0. Due to the slowly varying free surface, V1 and V2 are also equal to 0. This allows for equation 1 to become simplified. Using this simplified expression, plug in your known values and solve for V. We continue on with step 6 by using our equation 2, which is the flow rate equation. Using the known values and the calculated V, which is equal to 5.4 meters per second, solve for Q. Q is equal to 0.38 meters cubed per second. Next, we will relate the manometer equation to the flow equation. First, we will use equation 3, the manometer equation, and simplify it to find the change in pressure and set that equal to the specific gravity minus 1 times the unit weight of water times the height. Next, we will use the pipe energy equation and rearrange to also set that equal to the change in pressure. Then, we can set the pipe equation and the manometer equation expressions equal to each other and solve for the manometer deflection, H. Our final answer, the determined manometer deflection, is 0.47 meters. Thank you for joining us at Zen 340. We hope we've helped you find your inner peace today. And as we end all Zen 340 sessions, Namaste.